We can also get really general to a problem that isn't even projectile motion, but is still a 2D kinematics problem. And here we have a spaceship that's at the origin of a coordinate system at t equals 0. My equal sign is kind of mangled, sorry about that. At t equals 0. It is moving at 76 meters per second at 49 degrees above the minus x-axis, and is accelerating at 11.2 meters per second squared at 28 degrees above the plus x-axis. So, if you're ever having trouble visualizing a problem, it can help to draw it. But what's happening is that you've got your spaceship here, and it's heading off in this direction. Okay, this is its velocity, but its acceleration is off in this direction. So with that, it's going to be moving this way, but then as it's accelerating this way, it'll kind of follow a curved path as it moves along. So the first question I'm going to ask is, what is its displacement at t equals 22 seconds? Okay, well, to figure this out, we can just use our kinematic equations. We've got a time-dependent equation in the x direction, we have a time-dependent equation in the y direction. So in the x direction, we have our position equals x naught, which is 0, plus v naught x t. Well, our velocity is 49 degrees above the minus x-axis. That's negative, that's this way, so it's minus 76 cosine 49, and then above the minus x-axis, so the y component's positive, and then 76 sine 49. Our acceleration vector is at 11.2 meters per second at 28 degrees above the plus x-axis, so that's a positive 11.2 cosine 28 and a positive 11.2 sine 28. Now, you can write this out as two equations, or you could write this out in vector form. I'll write it out in two equations because I think it's simpler to see what's going on there. So in the x direction, we have our x position equals x naught is 0, v naught x is minus 76 cosine 49, t is 22. Our acceleration in the x direction, plus 1/2, 11.2 cosine 28. Don't forget about this 1/2. It's easy to forget since we don't explicitly write 1/2 when we're doing projectile motion because we write 4.9, but remember that's half of 9.8. The half is still part of the formula, so make sure you include the half in there. And then times time, which is 22, and again, don't forget to square, that's easy to forget. And if we punch that in the calculator, minus 76 cosine 49. By the way, for all of these, make sure you're in degree mode. It would be most unfortunate if you lost points because you were in radian mode. Times 22 squared. And we get that our x position is 1296.2 meters. In the y direction, we can similarly write out our equation. We can y naught is 0 because we're at the origin. V naught y is 76 sine 49. T is 22 plus 1/2, 11.2 sine 28 times 22 squared. And again, you can punch that in. Oops, it's very similar. I'm just replacing the cosines with sines, and then first one became positive. And so our y position is 2534. So we're done. Or are we? We're not really done, because displacement, remember, is magnitude and direction. I'm going to go back and store these because I forgot to do that. Store as y. Okay. Our displacement is magnitude and direction, so take the square root of x squared plus y squared to get our how far we are from the origin. Square root x squared plus y squared, and we get 2846.5, so 28, call that 2847 meters. And our angle, arctan of y over x, gives us 62.9 degrees. And where is that? Well, both x and y are positive, so that is 2847 meters at 62.9 degrees above the plus x axis. The dash, by the way, not a minus. Oops, above the plus x axis. All right. I could also ask you some other things. I could say, how long does it take to get back to the y-axis? So we know the spaceship's going to take a kind of curved path. Well, it's going to cross this y-axis at some point. So when is that going to happen? Turn your phones off, people. All right. And this is relatively simple. What do we know about at the y-axis? Well, at the y-axis, x equals 0. So we can go back to this equation, and we plug in x equals 0, and everything, our initial velocity is the same. Instead of 22, we put in just t plus 1/2 times 11.2 cosine 28 times t squared. So this, we factor this out a t, then we get that t equals 0, but that's at the start of the problem, and that's not what we care about. So that's, from there we can cancel out the t, and then we just have minus 76 cosine 49 divided by, when we move it over to the other side, when we move this over to the other side, it becomes positive, so it's just 76 cosine 49 divided by 0.5, oops, parentheses, 0.5 times 11.2 cosine 28. So we get that our time is 10.08 seconds for when it crosses the x-axis again. So in the general case, you know, we're applying the same equations. It's just that these same equations, there they are. It's just that we don't have the luxury of compressing them based on things that are 0 or things that we know are 9.8 or whatever. But we can still do problems in the very general case.